Hello, everyone, and welcome to DevOps Stage 2021. My name is Volodymyr Shynkar, and today we're going to talk about Kubernetes and container security. A little bit about myself. I'm DevOps engineering lead at Intellias. With 9 years of commercial experience, I had successfully migrated, deployed, and advised more than 15 projects in different domains. Also, I'm actively participating in Center of Excellence and Technology Office in Intellias. On today's talk, we'll discuss 4 sections. The first, we will review general principles and then move to the container and Kubernetes security. In the end, we will use several tools for checking the security of your cluster. So in this session, you will know more about things that you might want to use in your infrastructure. It's like container scans, limiting access, network tuning, improving security, and scan your cluster for potential vulnerabilities. Now let's switch to general overview. We had several infrastructure layers, and each of them has an attack surface. At the first layer in the cluster, it's a cluster instances where your workloads are running, and then the cluster and container itself. Our goal is to reduce the attack surface, and that is what we are going to do today. So let's start from the cloud and instances. We will not be focusing on this so much. Let's quickly review a few points that you can easily improve without changing internals of your cluster. By implementing this, we need to keep in mind the principle of least privilege. And yeah, this principle should be followed at each stage. So just make sure that your cluster is deployed into the private subnet and traffic is going from load balancer and services like ingress. Do not expose any management ports like SSH or ADP. Try to use SSM or even nothing, since the Kubernetes doesn't require much of underlying system configuration. Furthermore, using managed Kubernetes service, you don't even need to worry about initial setup. You will just manage workers. Now it's time to move to container security. Let's review the best practices for Dockerfiles. I'm just kidding, we're not going to review all these lists. We will have only few things that are related to container security, but not those. And the first one is unprivileged root user or rootless. By default, many container services run as the privileged root user, and application executes inside the container as root without a need of privileged executions. Prevent root execution by using non-root containers or rootless containers limits the impact of container compromising. And the next one is immutable container file system, which prevents from creating files, downloading scripts, and modifying the application within the container. However, this limitation also affects legitimate container applications and can potentially result in crashes or unexpected behaviors. To prevent damaging legitimate applications, you can mount secondary read-write file system for specific directories where application can require write access. The next one is distroless images, which contains only your application and its runtime dependencies. They do not contain package managers, shells, or any other programs you would expect to find in standard Linux distributions. The next one is the default way of building and then shipping the container into the your application into the other container. As you can see here, on the example, first we build application, then just copy the binary to the distroless container without any dependencies. And the last one, it's a secret. Try to avoid baking your secrets inside the containers, but instead use Kubernetes secrets, which mount as a volume and used to pass sensitive information, such as password to your pods. And of course, do not forget to scan your images. And the good news that Docker and Snyk recently entered into a partnership to provide container vulnerability scanning. What does it mean for you? Snyk is now integrated into the Docker Hub to scan the official images, Additionally, Docker has integrated Snyk into the Docker clients, which means you can now integrate it in one command to scan your images in your CI. Of course, you can use other providers like Quay, but that services requires more integration and configurations. In addition, services like Docker Hub, AWS ACR, Quay provides images scanning after you push the images, but while you'll be fixing those vulnerabilities, the image might already be used in production or other environment. There are also several services that can be deployed like Docker Bench Security, which will execute checks inside your cluster. Still, it is not necessary since we have a pod security policy and open policy agent, which will cover most of our security enforcement. We will talk about that later. This topic will be a little bit bigger and more complicated, since we'll be talking about network, protocols, tools, different approaches, and policies. We're going to walk through all of them, and for those who had recently started working with Kubernetes, some of these topics might be too complex. So if you don't understand some of those, please leave a question, and I will be happy to provide more extended answer. We are good? Great, let's begin. The first thing that we are facing working with Kubernetes is how I can deploy system operators and project workloads into the cluster. Oh, I have a CLI tool, why not to use it? Yes, you can, but that doesn't mean that it's the right way. Our workloads should be structured as packages and deployed with some flexibility. For that, we have a Helm. Helm helps us to deploy the same YAML files, but with templating powers such as variables and conditions. Also, it has revision history, which support rollbacks. So yeah, Helm will make your life easier. Furthermore, almost all services provide their own Helm charts, and you can install them in one click. It's the same simple as install package on Linux, but that's just the beginning. Now we have lots of Helm charts, how we can automate them and deploy in secure way. There are two approaches for that, the push-based and the pull-based. The push-based I call classic way. It's something familiar for all of us because we use it on daily basis. For instance, you have a task to build CI/CD process. You chose CI system, you build and push artifact, and then trigger deployment directly from CI. This is the easiest way, and it has great benefits like feedback. Our job is green, perfect. Release is successful. But of course, it has pitfalls. First, you have to provide an access to the cluster from CI, and usually it's in admin permissions. Second, the application state might be changed since the last release, or for example, someone had modified some configuration, and your CI system will be broken. Thus, with an admin access, CI can easily apply, modify, or remove other resources. Of course, that also applies to developers. To avoid that, we can use other approach, which is the pull-based, or the other name, GitOps approach, is based on the operator running inside your cluster. It monitors the repository for the changes and applies it automatically. Since operator has an access to the repo, we don't need to provide an access to the cluster from CI system, which significantly improves the security. Benefits from using this approach is that you always have a source of truth, and it's your repository. Moreover, these tools will override any changes which were made manually by someone, so we will never have the configuration drift. We have two candidates here, and it's Flux and Argo CD. Let's focus on the Argo since it has more features and nice UI. So this is an example of configuration for Argo CD, and basically this one describes the application, especially your Helm chart. We set here the repository link, the branch from where we would like to monitor and use the resources, path to the chart, and the other like namespace, Kubernetes, URL, I mean server, and that's it. And the other example, app project. So projects provide a logical grouping of applications, which is useful when Argo CD is used by multiple teams. It has several features like restrict what may be deployed, restrict what kind of objects might not be deployed. For instance, airbag or CRDs, or for example, you don't want to allow daemon sets or network policies. Anything like which has some compatibilities or anything else. And we can assign applications to these projects and prevent charts from getting an admin access, or for example, someone adds some permissions to their charts and they will be just blocked from that. And of course, from security features, you can easily share this Argo CD dashboard, since it allows you to browse resources which basically you have deployed, and they will not see the secrets from the UI. So for example, you might want to share it with developers and support guys. That's okay. They will only see what they deployed, and the sensitive information will not be leaked from there, because you assume that that's trusted people. Finally, we come to the pod security policy. Remember, at the container security, we were discussing non-root containers, read-only file system, and other compatibilities such as passing Docker socket or running pods in the host network. With pod security policy, we can enforce and prevent pods from executing unless these requirements are satisfied. Here is a simple example with enforcing two policies: privileged to false and must run as non-root user. After applying this policy, it will not be enforced, because you also need to activate it by adding a bug in order to tell where exactly this policy should be applied. As you can see, that it's not so easy, and along with the policy, you need to worry about other configurations, and it's not always obvious how to use them. That's why pod security policy will be deprecated in the near future. But the pod security policy is not the one thing that we can use to enforce security features. We have Open Policy Agent. So Open Policy Agent, basically Gatekeeper, is the policy engine that evaluates requests to determine whether they conform to policies or not. With this tool, we can expand our control over the resources that will be created. We can enforce things like labels, requesting limits, and by the way, this one is essentials when you want to scale your cluster. We can even deny container registers other than trusted, and allow only corporate or, for example, Amazon ACR. With Gatekeeper, you can enforce anything that present in your YAML files. But like any powerful tool, it has a pretty complicated policy syntax. Basically, it's a Rego language. Let me show you an example. On this screenshot, we have a policy for enforcing container registers. And I have no idea how to write on Rego, so it's just an example that I was using from the library provided by Gatekeeper guys at the GitHub. So this config is just a template, and the arguments to this are in the following example. So once you create template, Gatekeeper will transfer it into the CRD, and then you can refer to it. As you can see here, we apply this policy to the pods and namespace default, but you can specify several namespaces here, so don't not focus on that. And in the end, we have a list of registers that we want to trust. So the worst part here is writing templates, which anyway can be Googled, and the rest is not so complicated. And here in the bottom, you can see the link for more policy examples. I hope that Open Policy Agent wasn't that hard for you. And now let's move to the network policies. Fortunately, network policies are way easier to use compared to Gatekeeper. Let's review the example on this slide. As you may know, Kubernetes namespaces are not insulated from each other, and any pod can talk to any other pod, which is not good, especially when you have some services with sensitive data or monitoring, which should have an access only to the metrics port. Another example, when you have a multi-tenant cluster that hosts workloads from different clients, and you need to be sure that they will not interact with each other. The other example is when you need to allow traffic from other namespace based on labels. And yes, if you want to hack the system, you can run a pod in a test namespace with a prod label, and yeah, your traffic will be allowed. But that's not always critical. And if you really worry about that, you can always enforce correct labels by using the same Open Policy Agent. By the way, to make network policy work, you need to install a CNI which supports that. And Calico is a good candidate. Yeah, Amazon AKS has their own network plugin, and as an option, you can use a security groups for pods and manage access from Amazon console. The last example is limiting by port. To be exact, allow traffic to the metrics port only for monitoring tools. One more remark regarding Amazon CNI. If you use custom networking, the network policies will lose their force. So you have to choose which policies to use. The next topic is secrets. Everyone is facing with the question of how we can securely deliver sensitive information into the cluster and not worry about leaks. I hope that you're not keeping your passwords at the stickers, right? The good candidate for managing your secrets is Bitnami Sealed Secret. You just need to encrypt secret value using the encryption key and then create a YAML file with it, and you're ready to go. Other alternative is Gitcrypt, which encrypts files using trusted GPG key, and you can decrypt only by other trusted key. This one is not the best for Kubernetes secrets, but it's still good for other sensitive data like private keys or kubeconfig. On this example, you can see the sealed secret, and as you can see, the value is encrypted. Once you deploy this file into the cluster, the Bitnami operator will convert it and decrypt this file into the regular secret, like this one. As you can see, now our sealed secret is a regular secret. And remember Argo CD? You can easily share the Argo CD dashboard with developers and support guys, as we were talking about before, but just make sure that they have read-only access, right? And the last topic is hardening of Kubernetes itself. The API cluster, the core of Kubernetes. On some self-managed clusters on older versions, the API servers run not only at HTTPS, but also on unsecured port, which bypasses authentication and authorization checks. So if not good people get access to the API server, then they become Kubernetes admins. Thus, make sure that you have disabled an insecure port, or just try to curl to the port 8080 to see if you have any reply. Next one is etcd. It's like database which stores cluster information and cluster secrets. It's a really critical component of Kubernetes, and in case if anyone who can write to etcd, they can effectively control your Kubernetes cluster. Even just read-only access can easily provide helpful hints to the attackers. So the etcd server should be configured to only to reply only to the trust certificates, which should be in API server. Therefore, you will be more secured. Another guy in the cluster is Kubelet. It's an agent that receives instructions what to do and basically responsible to scheduling your workloads in the cluster. So yeah, same story. Check for the anonymous access and the right authorization mode, and you'll be safe. And of course, Kubernetes dashboard. I would disable it completely since we have other tools which can help us to understand cluster status. The same Argo CD. Yes, you'll be seeing only the resources that you have created by Argo. But on the other hand, it's great because usually issues are coming from the project workloads and the cluster itself is quite stable. And in the end, I have prepared a table with a list of ports that you may want to check at your cluster. You can make a screenshot and wait for the presentation after the event. But that's not all. I have a few tools which you can find, which can help you to find vulnerabilities for you. And the first one is Kubescape. To run this tool, you just need to execute 2 commands locally to download script, and second, to execute it. The result will be the list of vulnerabilities and misconfigurations with some summary. And in the end, general score. Remember Kubernetes hardening recommendations? This tool will check it for you, plus other things that you might have potential issues. In addition, this tool uses database which updates accordingly if some new vulnerabilities was detected, and it soon will be here. The next one, Kubebench. It's almost the same as Kubescape, except it executes inside the cluster and can be deployed as cron job for regular scans. So if you configure it properly, you will receive a notification about some critical issues to your email or to some other system that you use. Next one is Kubersec. It's a simple plugin for scanning Kubernetes pods. The result will show you which user it runs, or if root user inside, limits, requests, everything that we talked previously about hardening your pods, it will show you here. And Kube Audit, it's similar to the features from Kubersec, but it has more widely output and generates a good list with examples that helps you with fixing these issues. So I would recommend you this one more. And the last tool is more for debugging your pods, but it might be used for attackers to sniff your traffic for sensitive data, since often internal traffic is not encrypted. But anyway, this tool is very useful when you need to analyze traffic for some of your pods. Finally, we come to demo. Let me show you a few examples that about things that we were talking about on previous slides. As you can see here, I have Argo CD, which is deployed on Minikube on my laptop. I have already installed a few applications here. Basically, it's Sealed Secret, it's Gatekeeper, and demo application, which we'll be using for applying our policies. Argo allows is an additional application which is helps my application to work because it uses custom CRDs. Anyway, this is how my application looks. We have here deployment, service, ingress, custom resource rollout. And basically that's it. We have 2 pods, nothing really special. Let's have a look to the deployment, which we have here. Nothing special. We have here Ubuntu latest with a simple sleep command. And also I have prepared a few things that we will be using during demo. Currently, as I mentioned, we have Ubuntu, which is run on root user. So it means that it's currently privileged. And not privileged, it's just like not following our practices. Also, I have added this read-only file system to true and privilege it to false because we will need it later. Okay. Oh. All right. I have a few files here. Basically, it's open policy agent rules and a few other things that we'll be using here. First thing that I would like to test is create sealed secret. We need to uncomment this secret here and also uncomment this guy here. So basically, this is an example of sealed secret with encrypted value. Also, important thing that when you will be creating this secrets, you need to specify the usage of this secret, because if you create a specific secret for a specific namespace, it will not work. So you have to specify whether the namespace or cluster wide. On deployment, we have reference on 2 places to this secret. First, as a volume, then we use volume mount. Second is just as an environment variable. Let's commit these changes and see what we have. Good. Since we use Argo CD and Git repository, once we push the changes, we need to wait for a while, or we can force refresh. And Argo CD applies our changes instead of us. As you can see here, we have new resource sealed secret, which has already created a secret for us. The secret value, of course, will be hidden. And we have a rollout, which is basically doing the canary deployment. Let's not focus on that. Let's just promote it to the next replicas. Perfect. We have a pods. Let's see what we have there. We have this pod here, and let's execute it. Okay. So let's check what we have for environment variables. And as you can see, my API key equals to QWERTY op, which is basically the value for my secret, but it's encrypted. And as you can see in deployment, I have set environment variable name to my API key and value from secret. And that's exactly what we have here. Let's check the volume. Yes, because we have specified a path here, ATC demo secret. Right. It has created a folder with a name of which we specified, and the key to the API key, the same value, QWERTY op. So basically, how does it work? We have a secret, and we can add several values here. It could be API key or another, and it will create a separated file per each from here. Remember, I was showing you that we have Ubuntu, and it's currently runs under the root user. Let's see what we can do with Open Policy Agent. Oh, we're still in container. I have created these files with rules. Let's see what we have here. Remember, I was describing you Open Pod Security Policy. So basically, with Open Policy Agent, you can do the same. And that's the way easier. I know that that Rego language is hard, but you can Google any example. Let's apply it. We have applied this one. And we need other. And other is this one. So this one is for restricting the container registries. We will also test that. So we have created two templates. They are not yet enforced because we need to tell where exactly we want to apply it. We can apply it to the namespace or to the cluster itself, I mean to the whole cluster. For that, we need these policies. As you can see here, we have a list of repositories. It's basically Open Policy Agent, QA, and some ACR repository. We have specified a namespace default and applies to the pod. We want to apply this file for demo namespace since our application currently deployed to that namespace. Perfect. What we need to do next? We have an application here, and we can delete to make sure that pods will be scheduled once again. And what is going to happen right now? Let's wait for a while pods will be terminated. And we can see an error, which is basically error creating administrative hook, the repository Ubuntu latest not allowed, and allow this, this, and this. Perfect. Let's remove this rule because currently we don't need them anymore. Great. And let's test the other one. Oh, basically, yeah, we can try to do it once again. Oh, yep. See, once we delete the pods, delete the rule, pods were scheduled, but I accidentally deleted right away in the same time. I mean, all right, we need apply this one. This one is for enforcing the privileged, preventing from running on privileged as containers. I'm going to apply it only for demo namespace the same, because then our cluster behaves in like really unexpectedly. Great. In order to test that, what we need to do, we need to change privilege to true. Let's push our changes and the moment of truth. New pods are going to be created. And the same. Admission webhook, privilege true, not allowed. Sorry. You can create it. And of course, we have read-only file system. I think we can test it to see how it works. Perfect. The same replica because nothing changed. Let's copy name from here. Okay, I'm in. And I would like to create a file. Oh, sorry, you can't. And that's a really good thing because usually if someone wants to do something with your system, like install some additional tools in order to scan your network or modify your application, and this will prevent him from doing that. So we cool. The next thing is show you how the perfect application should looks like. We need false. Let's change it. We have a default here. And this should be removed. The default image is rollouts demo. So basically a container provided by Argo. And push. The new pods with new application is going to be created. Basically, one is already created. Let's promote this application. Oh. Okay. So we have a new pod here. Let's try to execute and get into it. Nope, bash isn't there. Sage, nope. Environment variables, nope. Cat, no. Dog, no. So as you can see, this container doesn't have literally anything. So you can see that even if you have installed some dependencies that has critical vulnerabilities, and with enforcing this kind of requirements, the attackers will not have enough power to just get the information from your cluster. Okay, the next things that I would like to show you is the tools that we were discussing a few minutes ago, and the Kubescape. It's basically two commands. One is to download the script, and second is scan. As you can see here, we exclude namespaces because kubesystem is basically default, which should be configured correctly. That's my password. Oh. Right. And after a few seconds, we have a report. Also, you can see more information on provided. Oh, we need to log in here. So what we have here: host network access, symlinks, resource policies, privilege controllers, non-root containers, network policies, other. So all this information is structured, and you can see where you need to improve, what you need to improve, and where you're good or where you're not good. Above the list, what exactly is not good. So here we have things for Argo CD like resource and limits are not set here. It's basically nothing really critical for this minikube, but generally for the cluster, it's really important. Network policies is not here. Linux hardening also not satisfied, and etc. The next one is Kubebench, I guess. Yep, it's Kubebench. And it works through the job and executes inside your cluster. We have job here. Simple job. Simple as that. Completed. Perfect. Let's see. Let's read logs from there. And here we have a report. Summary, 24 warnings, pass, 30 fails, 46 warning. And here you can see the whole list, what exactly wrong and not good with your cluster. Remind you, I'm running it on Minikube, so it could be that I have lots of things not well configured because it's just default configurations that I have here. kubectl or just kube security. This one is also good. Let's see what we have here. Let's scan our demo application. I have already installed this plugin. Scan -n demo pod. And what is the name of the pod? This one. All right. It's just saying that I need to add a few more things to avoid bad things. I mean, like add capabilities drop, run user of this, etc. So this also is clear. And the last one is kube audit. It's basically a little bit powerful, a more powerful tool than this one, kube security. It's also plugin, and you can run it for all resources like kubectl, audit, all. And as you can see here, the summary about everything that I have here. Capability, security, context missing, limits not set, run as root, allow privileged escalation, etc. All these tools are pretty similar and do really almost the same stuff, but you can check each one and see what exactly they are saying. Maybe one has not enough information about one resources and the other has more information. So we can compare all of this and choose which tool you would like to use. So this is all for demo. Let's move forward. And that's it for today. I hope you have enjoyed this talk, and based on this information, you will make your cluster hackers proof. Thanks everyone who had stayed until this moment. Let's get connected on LinkedIn and see you there. Bye.